Hello students, I am Dr. R. Krishnakumari, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Katangulathur. Today we are going to see few topics based on vector calculus. Let us see the outline of this module. Today we are going to see about line integral followed by surface integral, then volume integral. Then we are going to see about three important theorems, that is Green's theorem, Stoke's theorem and Gauss divergence theorem. Line integral. An integral which is evaluated along a curve is called a line integral. A line integral f over c is denoted by integral of f vector dr vector. Work done by a force. If f vector x, y, z is a force acting on a particle which moves along a given curve c, then the integral f vector dr vector gives the total work done by the force f vector in the displacement along c. Thus, work done by a force f vector is equal to integral of f vector dr vector. Let us see the sums based on line integral. If f vector is equal to 3xy I vector minus y square j vector, evaluate integral of f vector dr vector where c is the curve, y is equal to 2x square from the points 0, 0 to the points 1, 2. So it is given that f vector is equal to 3xy I vector minus y2 j vector, and dr vector is going to be dx I vector plus dy j vector. Therefore, the dot product of f vector dr vector is going to be equal to 3xy dx minus y square dy, and it is given that the c is equal to y is equal to 2x square. Therefore, dy is going to be 4x dx, and they have also given that the points x varies from 0 to 1. Therefore, integral of f vector dr vector is going to be the integral in the limits 0 to 1, 3x 2x square dx minus 4x power 4 into 4x dx. Therefore, while simplifying, we will be getting the value of 6x power 4 divided by 4 minus 16x power 6 by 6. So, this is going to be equal to minus 7 by 6. Find the work done when a force F vector is equal to x square minus y square plus x I vector minus 2xy plus y j vector moves a particle from the origin to the point 1, 1 along y square equal to x. So they have given that the F vector is equal to x square minus y square plus x into I vector minus 2xy plus y into j vector. So we know that dr vector is equal to dx I vector plus dy j vector. Therefore, the dot product of F vector dr vector is going to be equal to x square minus y square plus x dx minus 2xy plus y dy. They have given that y square is equal to x. Therefore, 2y dy is going to be equal to dx, and they have given that the y varies from the points 0 to 1, since they have said that the given the force moves a particle from the origin to the point 1, 1. Therefore, integral of f vector dr vector is going to be equal to integral of 0 to 1 y square the whole square minus y square plus y square 2y dy minus 2y square y plus y dy. So, if we simplify this, we will be getting the value of as 2 y power 6 by 6 minus 2 y power 4 by 4 minus 2 y square by 2 with the upper limit 1 and the lower limit 0. So when we simplify this by using the upper limit and the lower limit in the place of y, we will be arriving at the answer as minus 2 by 3. Now let us see about surface integral. An integral which is evaluated over a surface is called a surface integral. So consider a surface S. Let f vector be a vector valued function which is defined at each point on the surface, and let p be any point on the surface, and n vector be the unit outward normal to the surface at p. Then the normal component of f vector at p is defined by the dot product f vector into n vector. The integral of the normal component of f vector is denoted by the double integral of the dot product f vector into n vector ds, and it is called as the surface integral. Evaluation of a surface integral. So these are some important points necessary for evaluating a surface integral. So let R1 be the projection of S on the xy plane, and let k vector be the unit vector normal to the xy plane. Then ds is going to be equal to dx dy divided by the magnitude of the dot product of n vector and k vector. Therefore, the double integral of the dot product f vector n vector ds is going to be equal to the double integral over r1 f vector dot product of n vector dx dy divided by the magnitude of the dot product of n vector and k vector. So this is going to be the similar formula for R2 and R3 if R2 is the projection of S on YZ plane and if R3 is going to be the projection of S on XZ plane. Evaluate double integral of the dot product f vector n vector ds if f vector is equal to x plus y square I vector minus 2x j vector plus 2yz k vector and S is the surface of the plane 2x plus y plus 2z equal to 6 in the first octant. So given that f vector is equal to x plus y square I vector minus 2xj plus 2yz k vector. So let phi is equal to 2x plus 2y plus 2z minus 6. So we know that the formula to find del phi is equal to I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So now we have to differentiate phi with respect to x, then with respect to y and then with respect to z. So if we differentiate, so we will be getting the answer as 2i vector plus 1j vector plus 2k vector. Then the magnitude of del phi is going to be equal to the root of 4 plus 1 plus 4. So which is going to be equal to root of 9. So which is going to be equal to 3. So now n cap is going to be equal to del phi divided by the magnitude of del phi. So which is going to be equal to 2i vector plus 1j vector plus 2k vector divided by 3. So the dot product of f vector n cap is going to be equal to x plus y square I vector minus 2x j vector plus 2yz k vector into the dot product of 2i vector plus 1j vector plus 2k vector divided by 3. So by simplifying we will be getting 2 by 3 y square plus 2yz. Further simplification we will be getting it as 2 by 3 y into 6 minus 2x since 2z is equal to 6 minus 2x minus y. Therefore 4 by 3 y into 3 minus x. Now let R be the projection of S on the xy plane. Therefore ds is equal to dx dy divided by the magnitude of n cap by the magnitude of the dot product of n cap and k vector. Therefore n cap into k vector is going to be equal to 2i vector plus 1j vector plus 2k vector divided by 3 to the dot product of k vector. So that is going to be equal to 2 by 3. Therefore the double integral of the dot product of f vector n cap ds is going to be the double integral of f vector n cap dx dy divided by the magnitude of the dot product of n cap k vector. So by applying the values over here, we will be getting it as 2 times of the double integral of 3 minus x y dx. Now we have to integrate it twice. So here y varies from 0 to 6 since in R1 2x plus y is equal to 6. X varies from 0 to 6 minus y by 2. So by applying the lower limit as 0 and the upper limit as 6 with respect to the outer integral with respect to y and the lower limit as 0 and the upper limit as 6 minus y by 2 with respect to x. Now we can solve this double integration. So first we have to solve the innermost integral. So by solving y into 3 minus x with respect to x, we will be getting it as 3x minus x square by 2 with the lower limit is 0 and the upper limit 6 minus y by 2. So now we have to apply the upper and the lower limit in the place of x with a minus in between. Then we will be getting it as 2 into integral of 0 to 6 y into 3 into 6 minus y divided by 2 minus 1 by 2 6 minus y by y square by 2 the whole square dy. So now when we simplify this, we will be getting the answer as 2 times of integral of 0 to 6 1 by 2 18y minus 3y square minus 1 by 8 6 minus y the whole square dy. Now we are going to apply the integral with respect to y. So now if we integrate with respect to y, we will be getting the answer as 2 by 2 18y square by 2 minus 3y cube by 3 minus 1 by 8 6 minus y cube by 3 into minus 1. So if we simplify this, we will be getting the answer as 81. Next we are going to see about volume integral. An integral which is evaluated over a volume bounded by a surface is called a volume integral. So if f vector is equal to f1 I vector plus f2 j vector plus f3 k vector is a vector field in V, then the volume integral is defined by the triple integral f vector dV. So now let us see sums based on the volume integral. So if f vector is equal to 2x square minus 3z I vector minus 2xy j vector minus 2x minus 4x k vector, evaluate the triple integral of the cross product del f vector dv, where V is the volume of the region bounded by x is equal to 0, y is equal to 0, z is equal to 0 and 2x plus 2y plus z is equal to 4. So here they have given the value of f vector as 2x square minus 3z I vector minus 2xy j vector minus 4x k vector. So by using the cross product concept, del cross product of the del f vector is going to be equal to j vector minus 2y k vector by using the determinant. Now for limits, given x is equal to 0, y is equal to 0 and z is equal to 0 and 2x plus 2y plus z is equal to 4. Therefore, z is going to be z is equal to 0. Therefore, this implies that 4 minus 2x minus 2y, and by putting z is equal to 0, we will be getting the equation as x plus y is equal to 4, and by putting z is equal to 0 and y is equal to 0, we will be getting the value for x is as 2, for x is equal to going to be. Now by using these limits in the triple integration, we will be getting the volume integral as triple integral of the cross product of a del and f vector dv is going to be 0 to 2, 0 to 2 minus x and 0 to 4 minus 2x minus 2y, j vector minus 2y k vector dz dy dx. Now the innermost integral is going to be with respect to z, and the second innermost is going to be with respect to y, and the outermost is going to be with respect to x. So one by one we have to integrate to find the final volume integral value. So by first integrating the innermost one with respect to z, we will be getting the answer as integral 0 to 2, 0 to 2 minus x, j vector minus 2y, k vector z with the lower integral 0 and the upper integral 4 minus 2x minus 2y dy by dx. Now by applying the value over it, we will be getting the answer as 0 to 2 integral of 0 to 2, 0 to 2 minus x, 4 minus 2x minus 2y j vector minus 2y, 4 minus 2x minus 2y k vector dy by dz. Now by integrating this with respect to dy, we will be getting the answer as integral of 0 to 2, 4 minus 4x plus x square j vector minus k vector by 3, 16 minus 24x plus 12x square minus 2x cube dx. Now by integrating this with respect to dx, we will be getting an answer as 4x minus 2x square plus x cube divided by 3 with the lower limit 0 and an upper limit 2 j vector plus k vector divided by 3, 16x minus 12x square plus 4x cube minus x power 4 by 2 with a lower limit 0 and an upper limit 2. Now by applying the limits, we will be getting an answer as 8 by 3 j vector minus k vector. So here the triple integral concept is used fully. Now let us see what is meant by Green's theorem. Green's theorem relates a line integral to the double integral taken over the region bounded by the closed curve. So let us see the statement of Green's theorem. If m of x comma y and n of x comma y are continuous functions with continuous partial derivatives in a region R of the xy plane bounded by a simple closed curve C, then integral m dx plus n dy, that is the closed integral of m dx plus n dy, is going to be equal to the double integral dou n by dou x minus dou m by dou y dx dy. Here C is the curve described in the positive direction. Now the vector form of the Green's theorem is going to be the closed integral of the dot product of f vector dr vector equal to the double integral of the cross product of a del f vector into k vector dr. Now let us see sums based on Green's theorem. Using Green's theorem, evaluate integral of y minus sin x dx plus cos x dy, where C is the triangle bounded by y is equal to 0, x is equal to pi by 2 and y is equal to 2x by pi. So here I have shown the diagrammatic representation of the given question. So with this representation, we can find the limits that x varies from y pi by 2 to pi by 2 and y varies from 0 to 1. So we have to prove that the integral of m dx plus n dy is going to be equal to the double integral of dou n by dou x minus dou m by dou y dx dy. So here in the question they have mentioned that m is going to be equal to y minus sin x and n is going to be equal to cos x. So obviously dou m by dou y is going to be equal to 1 minus 0 and dou n by dou x is going to be equal to minus sin x. Now by applying these values we will be getting integral of 0 to 1 integral of y pi by 2 to pi by 2 minus sin x minus 1 dx dy. So first we have to integrate the innermost one with respect to x, then the outer one with respect to y. So by integrating the inner one with respect to x, we will be getting an answer as integral of 0 to 1 0 minus pi by 2 minus cos y pi by 2 plus y pi by 2 dy. Now integrating this with respect to y, we will be getting the value as minus pi by 2 minus 2 pi divided by pi sine pi by 2 plus pi by 4 when the limits 0 and 1 are applied in the place of y. Now by simplifying this, we will be getting an answer as minus pi by 4 plus 2 by pi. Now let us see the next theorem, Stoke's theorem. If S is an open surface bounded by a simple closed curve C, if f vector is continuous having continuous partial derivatives in S and C, then the integral of the dot product of f vector dr is equal to the double integral of the dot product of curl f vector n cap ds, or the integral of the dot product of f vector ds dr is going to be the double integral of the cross product of a del f vector n cap ds. So here n cap is the outward unit normal vector and C is traversed in the anti-clockwise direction. See a sum based on Stokes theorem. So evaluate the integral of the dot product of f vector dr vector by Stokes theorem, where f vector is equal to y square I plus x square j plus x plus z k vector, and C is the boundary of the triangle with the vertices at 0, 0, 0, 1, 0, 0 and 1, 1, 0. So we know the Stokes theorem formula and they have given the value of f vector. So and they have also mentioned that C is a triangle with 3 points. So since z coordinate of each vertex is 0, the triangle is obviously lies in the xy plane with the corners 0, 0, 1, 0 and 1, 1. So to evaluate the double integral of curl of the dot product f vector n cap ds in xy plane, so we have to find curl f. So curl f is going to be the determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, y square, x square minus x plus z. So by using the determinant, and we will be getting the value of a curl as 2 into x minus y. So now by applying the limits for x that varies from y to 1 and y that varies from 0 to 1, we can find the double integral of the curl of the dot product f vector n cap. So which is going to be equal to 0 to 1, y to 1, 2 x minus y dx and dy. So now by differentiating with respect to x and by applying the lower limit y and upper limit 1, we will be getting the value of 2 into 0 to 1, 1 by 2 minus y square by 2 plus y square dy. And now by differentiating with respect to y, we will be getting the value as 2 into 1 by 2 minus 1 by 2 minus 1 by 6 plus 1 by 3 by applying the upper limit 1 and the lower limit 0. So by simplifying this, we will be getting the answer as 1 by 3. So now let us see the last topic, that is Gauss divergence theorem. So this theorem enables us to convert a surface integral of a vector function on a closed surface into a volume integral. So the statement of the Gauss divergence theorem is that if V is the volume bounded by a closed surface S, and if a vector function f vector is continuous and has continuous partial derivatives in V and on S, then the double integral of the dot product of f vector n cap ds is going to be equal to the triple integral of the dot product of del f vector dv. Let us see some based on Gauss divergence theorem. So using the divergence theorem of Gauss, evaluate the double integral of the dot product of f vector n cap, where f vector is equal to x cube I vector plus y cube j vector plus z cube k vector, and S is the sphere x square plus y square plus z square equal to a square. So they have given the value of f vector. So the dot product of del and f vector is going to be equal to 3 into x square plus y square plus z square. So by using the formula of the Gauss divergence theorem, so the double integral of the dot product of f vector n cap is going to be equal to 3 into the triple integral of x square plus y square plus z square dx dy dx. Now here we are going to use the spherical polar coordinates. So for spherical polar coordinate, x is going to be equal to r sine theta cos phi, y is going to be equal to r sine theta sin phi, and z is going to be equal to r cos theta. So by applying the values of x, y, and z in the form of theta, and the limits is going to be for x it going to vary from, I mean, for d phi, for phi it is going to vary from 0 to 2 pi, for theta it is going to vary from 0 to pi, and for r it is going to vary from 0 to a. So by applying these limits and by applying the values of x, y, and z as polar coordinates, we will be getting the integral as 3 into 0 to 2 pi, 0 to pi, 0 to a, r square sin theta dr d theta d phi. So by simplifying this, so now by further simplification, we will be getting it as 3a power 5 divided by 5 integral of 0 to 2 pi minus cos pi by cos 0 d phi. So which is going to be equal to 12 pi a power 5 divided by 5. This is going to be the end of the module. Thank you, students. Let us connect again in the next interesting topic. Thank you.